All right, welcome back. We are now on page 6. To complete this page, you may need your multiplication chart, number line, order of operations, prime numbers. You may need none of these, one or two of them, or all of them. Just make sure that you have your math folder ready. So page 6 says part 2, simplifying fraction expressions. Here, I can classify a fraction expression as a sum, difference, product, or quotient. And I can simplify fraction expressions with like and unlike denominators. Okay, so I need to classify it. What kind of problem is it? And I have to solve it. Okay, sometimes the bottom numbers will match. Sometimes they won't. And what makes this tricky is that we have all of them, sums and differences, are solved similarly. Products and quotients are solved another way, and they are all mixed together. So I really need to make sure that I'm paying attention to the signs. Okay. I'm going to scroll up here. And like I tend to do, I am going to black out, for those of us that benefit from that, the sections that we are not looking at yet. Okay. I'll even start with blocking out this one. Okay, so I'm looking at the first problem. And the very first thing we need to do is box our terms. So I hope you solve two terms because that is what I see. So I see two terms, and in the middle of them, I see a plus sign. That tells me that I am working with a sum. So in the upper right-hand corner, I'm going to write the first letter of the expression. Okay, so it'll either be a S, D, P, or Q. Now that I know I'm working with a sum, I need to look at the problem again. I see 1 over 2 plus 5 over 4. Now, 2 and 4 do not match. Okay, the denominators are not the same. I need to make them the same before I can continue. Now, the easiest way to do this while keeping the numbers as small as possible is to look at them a third time. Well, does 2 go into 4? You always want to find out if the numbers can go into each other, because that'll make one less step for us to do. And if I look, 2 does go into 4, 2 times. Nice. So I can write 2 over here, 2 on the top. Whatever we do to the bottom, we have to do to the top to keep the fraction true. So 2 times 1 is 2, and 2 times 2 is 4. Plus sign. I do not need to multiply anything to the other side because now the denominator is 4. Now they are matching. Because they are matching, I can continue to the next step. So when I'm looking at this, I see 2 plus 5. Now, if you want, you can use your number line 2. I'm going to add 5. 1, 2, 3, 4, 5. 2 plus 5 is 7. So this equals 7 over 4. I'm hoping that you see that this is an improper fraction because the numerator is bigger than the denominator. If you want to convert it to a mixed number, you can. However, I'm not requiring it for this review. Now, the next problem, we still box our terms first. Okay. So 4 over 3 gets one box, and 1 over 4 gets another box. Okay, fractions get one box because they are one term. They are quotients. And then here that says divided by. So I am dividing two quotients. I'm going to put a Q. Now, the denominators do not match, but do they have to match? We need to think back. And we also made rap songs or poems. Some people made different types of songs to try and remember the steps. So when we multiply and divide, the denominators do not need to match. But because this is a division problem, I need to switch the numbers on the right side. And I'm switching it because I'm turning this division problem into a multiplication problem. Because timesing is easier than dividing. So I keep my 4 over 3, I bring it down. I turn my division sign into a times sign with 4 on top and 1 on the bottom. Now this looks more manageable. Now I'm looking at 4 times 4. Go to my times chart just to make sure. Oops, why is it doing that? 4 times 1, 2, 3, 4 is 16. And 3 times 1 is 3. Again, you do not need to convert it to a mixed number, but you can. Moving on to the next problem. Multiplication problems get 1 box. Because it's one term. We do have 2 factors, right? 2 over 5 is factor 1, and negative 4 over 5 is factor 2. That's why I have 1 line here to represent the first fraction and 2 lines to represent the second fraction. My denominators match, but that doesn't matter. Okay. I want to see if I can simplify this in any way. When I look at 2 and 5 and 4 and 5, I'm looking at some prime numbers. So 2 and 5 are prime numbers. They are as small as they can get. And 4 does not go into 5 evenly. So this fraction, or this expression, is as small as it can get. So I will multiply across. 2 times 4 is 8. And 5 times 5 is 25. Notice when I'm multiplying, I multiply the denominators together. But when I'm adding or subtracting, the denominator stays the same. We can't forget our signs. So a positive and negative make negative. That problem is all done. Let's go to the next section. Now that we had a few warm-up problems together, I want you to start pausing the videos and trying the next row on your own. If you get stuck, you can play the video again. You can rewind and watch a different problem for an example. Okay. And then if you get it incorrect, that's fine. And you don't need to erase it. What I would like you to do is cross it off and then show me the correct way. Because when we're online, it's different. I can't see you live in the moment. And if I can see the way your brain was working when you did the problem, it will help me to see where you're at and how that will help me better support you. So please don't erase it. Okay, just cross it off, or even just, put a box around the correct one. Okay, it'll really help me understand where you're at with this. First things first. I hope you said, gotta box my terms. Because boxing the terms is the first step into solving problems correctly. It's showing that you understand the structure of math. Okay, got a division sign. Again, that's quotient. Now, Does 9 go into 7? No. 3 and 9? Yes, they do. Cool. Let me remember to write that in a different color. I don't know, purple, pink. Okay, so 9. How do I get 9 with 3? 3 times 3. Okay, and can 4 go into 7? No, not evenly. So now these cancel out. I can cross off 1, 3 on the top and 1, 3 on the bottom. We can put our dot and our 1, right? Anything, all integers always have an invisible 1 because 1 times any number is that same number. So when I need an extra visual, I bring it back up for a little while. Now that I have this written, let me clean it up for some people because it can be hard to read that way. So I'm going to bring down my negative. That's a 3 on top. Line 7. Oh, you know what? I just did this all wrong. Okay, just kidding. Teacher made a mistake. This is really good. I don't know what I was thinking. I just told you it was a division problem. Definitely a Monday. Do you feel like you're back in the classroom? Because I do. All right, I'm erasing this because if I were just to cross it out, it would make things so much worse. Teacher fails. Oh my goodness. Okay. All right. Forget everything I just said. Starting over. Okay. Quotient. 1 term, 2 terms. And I'm looking at the quotient, at the division sign. Okay. So I'm not doing that. What I'm doing instead, because this is a division problem, I hope you guys were thinking, aren't you supposed to switch it? Yes, we're absolutely supposed to switch it. Okay, I don't know what I was thinking. All right, so we're switching that and we're changing this to a multiplication. All right, so I have negative 9 over 7 times 3 over 4. Okay. Okay, now I'm looking, and 9 does not go into 4 or 7. 3 does not go into 7 or 4. So we multiply straight across. Okay, multiply across, multiply across, multiply across. 9 times 3 is 27. That looks like a Z, but it's a 2. 7 times 4 is 28. Okay. Well, that's a little bit better too. A negative times a positive is negative. Okay, so 27 over 28. I hope you caught my mistake. I would say I was just testing you, but I don't know. It's Monday. That's all I can say. Okay. So now I'm boxing my terms. Okay. In between these 2 boxes is a minus sign. That tells me I am dealing with difference. Okay. So 7 and 5, they don't go into each other. I know I need to make a match. So what I need to do is multiply each denominator by the opposite. I need to make sure I'm doing the numerator and denominator. So 5 on top, 5 on bottom, times, and then on this side goes 7. Okay. Now that I did that, the second step I need to do is multiply each of these. So 5 times 8, 40. You can double check it over here. 5 times 7 is 35. Notice that it's 5 less than times 8. Okay. Over 35. Bring down my minus sign. 6 times 7. Here's 6 to 7 is 42. And 5 times 7 is 35. Now, I know the number line does not go to 40, but since, 4 minus 4 is 0, we can just start the number line with 0, okay? And we'll add the 4 back in later. So I have 0, and I'm minusing 2, so I'm going 1, 2, okay? So 0 minus 2 is negative 2. 40 minus 42 is negative 2. Okay. So that gives me negative 2 over 35. Okay, coming over here. We cannot try to cross reduce these. Do you know why? Let's box our terms and find out. So pause the video so you can box your terms and find out if we match or not. Oh, there it goes. Okay. 1, 2. So even though there's a minus sign over here, after I box my terms, I can see that I need to classify it as a sum. Okay, since I'm adding, and see if they match. Yep, and when I add and subtract, I cannot try to cross reduce. Okay, I need to times 3 by 2, and on the top. What do I need to times 2 by? 3. Now that I have that, 2 times 2 is 4. We did that earlier, right? 2 times 3, 6. Notice how I'm checking a lot of my times numbers on my number line just to make sure that I'm doing it correctly. It's always best to check your work. Put my parenthesis and my negative sign, my fraction bar, another parenthesis. Okay. Now, 1 times 3 is 3, and 2 times 3 is still 6. So now I'm looking at 4 plus negative 3. So I have 4, and even though I'm adding a negative number, so I'm really going to the left, okay? So minus 3. 1, 2, 3, and I land on 1. So this equals 1 over 6. So I don't want these parentheses to confuse you to think that you're multiplying or multiplying a positive number or something like that. Parentheses can mean different things. So I have to make sure I understand what it's telling me. Because I was adding, the denominator stayed the same. Scroll down to the next. Black out what we don't need to look at. Right? What do we call that when I black this stuff out for you? Some of us starts with an M, masking. First thing I do is box my terms. So put a box and another box. All right, and I see it's a quotient. Okay. Hopefully I start dividing before I try to multiply, right? Gotta switch it. Rewrite it 2 over 3. Oh, better change that. Times negative over 7. All right. Does 8 go into 3 or 7? No. What about 2? No. All right. Multiply straight across. 2 times 8, 16. 3 times 7, 21. Negative and positive make negative. All right, negative 16 over 21. Next. I hope you're putting one box around yours. I just highlighted the whole thing. Can I make this? Oh, I don't know how to take off that highlight yet when I do that. All right, I got one box. And then one box is telling me it's a product because I'm multiplying them. So now that I'm multiplying, oh, 4 can totally, absolutely go into 4. Okay, so that's like saying it's a 1, or we can cancel that whole thing out. So I'm going to just draw a big line. Oh, try doing it this way. Okay, so those cancel out, right? Because 4 divided by 4 is 1. Okay, so it's like saying 1 times 1 and 1 times 3. So when I simplify it, it's 1 over 3, and that one's all done. Moving on to the next one. Box our terms. 4 over 5 and negative 3 over 4. Let's see. So 4 and 5, they do not go into each other. I need to multiply them by the opposite 1. So I put my 4s over here. I'm trying to get a little times looking thing. Times 5 and 5. 4 times 4 is 16. 4 times 5 is 20. Minus sign. Got negative over here. Keep that in there. Here's my fraction line. 3 times 5 is 15. 4 times 5 is 20. So now that my denominators match, I can just go straight across. Oh, but I have a minus, a negative number. That's a double negative. They are right next to each other, so they cancel out and become positive. So now I have 16 plus 15 over 20. Okay, so if this is hard for me to add, I can stack them up. Plus 15. Use my number line. 6 plus 5, 1, 2, 3, 4, 5 is 11. Need to remember to carry that 1 down here, and then I have 1, 2, 3. 31, so that equals 31 over 20. Something I have not mentioned yet, and I didn't put the difference over here, is if solving 4 different types of operations at the same time is confusing, we can break it down, okay? We can box our terms, and when we classify them, you can go back and just start with those. So after we mark all of these, looks like I left that one out too. I can go back and say, oh, well, I'm going to solve all the sums first. So you find your S's and you solve this problem. Then you come and solve that problem. Okay, that makes it easier because you're doing the same thing. When we did this before, when we covered the unit, I did have some of you guys do that, and it was helpful. Then you go and solve the differences. Why? Because we solve them in a similar way. right? We set up the problem the same. Then you'd go back and you'd do all the products, right? You'd find all the ones that had a P. There's a P, and then you go down and say this one's a P. So that's always an option. Okay, again, 31 over 20 is all done. You can convert it to a mixed number, but I am not requiring you to. We have one more row. Cover up what we don't need to look at. Box in terms. 5 over 8 and 1 over 2. Okay. Plus is a sum. Now, these numbers do not match, right? They are called unlike denominators, but I know that 2 goes into 8, right? Because 2 times 4 is 8. So 2 goes into 8 4 times. That means I want to put a 4 on the same side as the 2. I'm only doing the one side because I'm going to have 8. So I don't need to times anything on the other side, because then the number will not be 8 anymore. So 5 over 8 plus 1 times 4 is 4. And 2 times 4 is 8. So now that the denominators are matching, I can move on to the next step. 5 plus 4 is 9. You can check it on your number line. 9 over 8. You can convert it to a mixed number. Okay, if you want to write 1 and 1/8, that's fine. On to the next one. 1/3 minus 1/2. The minus sign makes it a difference. These numbers do not go into each other because they're both prime numbers. And since I know that, I am already going to times it by the opposite. Okay, got 2. Bottom, 3 on this side. Two times 1 is 2. 2 times 3 is 6. Minus 1 times 3 is 3. 2 times 3 is 6. Oops, I said 6 and I wrote 3. Just kidding. Try this again. There we go. Now I have 2 minus 3 over 6. Use your number line, because 2 minus 3 is not 1, right? You start at 2, your change is minus 3, 1, 2, 3, and I stop at -1. So it is -1 over 6. Moving on to the next. Box my terms. All right, 4 over 3 divided by 3 over 4. So I just said divided by, didn't I? Yes. If I'm saying divided by, it means I need to put a big Q right there. What else do I need to do? Oh, I gotta switch these, turn it into a times. So I got 4 over 3 times 4 over 3. And no, they do not cancel out because the 3's are both on the bottom and the 4's are both on the top. That means I need to multiply across. 4 times 4 is 16. 3 times 3, 9. 16 over 9, right? Feel free to convert it to a mixed number, but you don't have to. Okay. Move that mask, scroll down. We are reaching the bottom of page 6. Still masking. Now for the GCF means greatest common factor. When we did this before, we had to write down all the factors, but I think that we are a lot better at this now. And when we did this in Zoom, students did do this a lot better. So we want to find the biggest number that goes into 8 and 12. So I'm going to look at my times chart, and I'm looking at 8 and 12. I want, in the column, I want there to be an 8 and a 12. Well, 1 does, of course. And then 2 has an 8 and a 12. Okay, what about 3, 12, no 8, no. 4 has an 8 and a 12. What about 5 or 6? Nope. 5s only have zeros and 5s, right? 6, oh, has a 12 and an 18 and a 6. Nope. Okay, so 4 is the greatest common factor. Okay, so we can write this another way. Okay, so 4, oops, just kidding. 4 times 2 is 8, and 4 times 3 is 12. So the 4s, I'm going to write over here for my greatest common factor. Oh, I hate it when I do that. Oh, and the whole thing disappeared. All right. Let's try this again. 4 times 2 over 4 times 3. Those off. All right. So 2 over 3 is the simplified fraction, and 4 is the greatest common factor, the biggest number that goes into both 8 and 12. Okay, so I hope you get the idea. For the next one, we're going to do the same thing. Okay? I have 24 and 36. So which column has both 24 and 36 in it? 2 does, but I don't want the lowest number. I need the highest number. Okay? Let's see, is there 24? There's 24 and 36 and 3. Okay. What about 4? 24, 36 and 4. Okay. 5? Nope, because 24 and 36 do not end in a 5 or a 0. 6. 24 and 36. So there are a lot of factors already that I can choose from, but I want the biggest one. 7? Nope. Okay, what about 8? 24? No, 36. 9 has 36. 10? Nope. 11? Nope. 12. 12 has 24 and 36, both in them. 13 does not. Goes to 26 and 39. So 12 is the largest number I can use. So I'm going to write 12. 12 times 2 is 24. And 12 times 3 is 36. So my GCF, writing 12 over here, and 2 over 3. Do you notice how 8 over 12 and 24 over 36 both can be reduced to the same number? So these are 3 different ways of expressing the same amount. Okay, so we're going to do the same thing for 24 and 30. So we had 12, so start there. 24 and 36, nope. Okay, let's go to 9. Oh, it had 36, now I want 38. 24 and 32, not quite. 7 didn't work. Go down to 6. 6 has 24 and 30. So I feel like there was another one. We'll just start there. Okay, so 6 times 4, 24. 6 times 5 is 30. So 6 is our GCF, that's the greatest common factor, and I'm left with 4 over 5. Notice how I'm checking and using my multiplication chart each time to find the greatest common factor. We have 3 more. So I have 36 over 30, and I remember I could use 12, so I want to start with 12 because this is a bigger number. That means I can have a greater common factor. So I forgot the numbers already, 36 and 30. Okay, so it has 36, but not 30. Let's see. So that's not going to work. So I'm looking for somewhere where I have 36 and 30. Let's see, we have 3, right? 3 times 10 is 30. 3 times 12 is 36. So let's do that. So we'll do 3 times 12. And then 3 times 10. And then we can see that 12 and 10 share some of the same numbers. Okay, so I can make that even smaller. So 2 times 6 is 12, and 2 times 5 is 10. So I'm going to cross that off. Put 2 times 6. I want to show you guys another way we can do this. If we realize that the number wasn't actually the greatest common factor, so 2 times 5 is 10. Okay, so now I'm circling my 3 and my 2. 3 and 2. So if I times those together, 3 times 2 is 6. Because 6 times 6 is 36. And 6 times 5 is 30. I go to my times chart. We see, let me get my annotating pencil. Okay. So when we're doing 3, we can see 30 and 36. But when I do 6, I also get 30 and 36. They're right here. So that is why 6 is the greatest common factor. So with all the numbers, sometimes we can miss them. Back to here. Let me turn this back to my blue color I'm using today. So these I can cross off, and that makes my greatest common factor 6, and then 6 over 5 is the problem simplified. So if you were to write 3, you wouldn't get all full points because the number, even though 3 is a factor, 6 is the largest factor. Okay. I'm looking at this, 20 and 8. I want to know, does 8 go into 20 at all? No, it does not. Okay. So I need a number that has 20 and 8. So 4 times 5 is 20, and then 4 times 7 is 28. So number 8. Sorry. 4 times 2 is 8, and 4 times 5 is 20, right? And that's the only way we can get 8, right? 8 times 1, or you can do actually 2 times 2 times 2. But with 2 factors, 4 times 2 is 8. So I got 4 times 5. That looks like 5. That looks like a 3. That looks 4 times 5 is 20. 4 times 2 is 8. Cross those off. Okay. That makes 4 our GCF, and then 5 over 2 Again, with these two, you can turn them into mixed numbers, but I'm not requiring it. Now, does 9 go into 36? 9 times what is 36? 9 times 4. So over here, you can write 9. And 9 times what is 9? 1. Okay. And 9 times 4 is 36. Remember, the invisible 1, sometimes it's helpful. So these will cancel out and make that the greatest common factor. And the simplified version is 1 over 4. It's important that I include that 1 because if I don't, I may get confused and write 4 as my final answer. But 4 would be incorrect. 1/4 is the simplified fraction. And we are done with page 6.